Hey kiddos, today we're going to do more volume, but the shapes that we make when we do our rotations are going to be slightly different than Tuesday, just very, very slightly different. So here we have two curves and they've named them for us, f of x and g of x. So it looks like f is 3 root x, that must be this one. And this line is y equals 3 halves x. Now what they want us to do is to find the volume of the solid generated when the region is revolved about the line y equals 8. So that's not any different than anything you did before. We're going to use a calculator. We're going to round. It's going to be great. Here's the difference. So right now, let me make a cut here. When I do my rectangles, like I've always done, and I make my, my vertical cut so that it has a thickness of dx, this time when I follow that cut around the axis of rotation, which is up here. So we are rotating up here at y equals 8. When I follow that around, the shape that gets made here is not a circle anymore. It's a very sad looking donut, I guess. They're called washers. So they're circles, but they have another circle cut out of them. So if you pull it and lay it flat, you've got a big outside circle and an inside circle as well. And this is the ring that is part of the solid. So that's true all the way around. If I make a cut here, it's going to do the same thing. I'm not doing a super great job of like drawing the reflection, but that's where this rectangle goes. And it's this rectangle that is creating the solid. So that's what we need to find the area of so that we can add them all up and find the volume of the whole thing. Okay, so we all took geometry once. If I'm going to find the area of this ring, then I need to find the area of big circle and then subtract away the area of the hollow inside circle. So I need 2 radii. I'm going to use big R here, even though Delta likes to use big R to name the region, but that's the way you see it in a lot of books. So big R is your outside radius, like the big radius, and little r is your inside radius. So we're going to do pi, big circle squared, minus pi, little circle squared, little radius, big radius. That's going to find the area of one washer, and then we'll throw an integral on it with bounds to find the area, or to find the volume of the whole solid. Okay, so let's talk about how to find these radii. Radii are the heights of your rectangles. So remember that to find a vertical distance, we're going to do top minus bottom. Just be careful, because for this question, top is here. So your radius always starts at your axis of rotation and goes to your curve or to your region. So this outside radius starts at y equals 8 and then goes all the way down until it hits this outside curve, which is 3 halves x. So if I do top minus bottom, I've got 8 minus 3 halves x. And then it's going to be identical for the inside radius. The inside radius starts at your axis of rotation and just goes to your inside curve, the one closest to your axis of rotation. So this one would be 8 minus 3 root. And now I'm just doing areas of circles and subtracting them away. So big circle minus little circle. I'm going to put the pi on the outside, dx. And then my circles start at x equals 0 and stop at 4, if I read it left to right. And that is what you can type in very carefully. So the biggest mistake that I see on these kinds of questions that you certainly wouldn't do, because you'll get used to pulling the pi out. So it should be pi r squared minus r squared like this. What I see you children do is this. We all know those are not the same thing. You can't do r minus r and square the whole thing. All right, we're going to do it again, but I'm going to pick a different axis of rotation, and we're going to go vertically this time. So let's rotate around. I pick this line and I'm making it rainbow, so it'll be fun, or at least pretend to be fun. That wasn't very good. We're going to rotate around this line, x equals -1. That's going to be our axis of rotation. So if you have not yet figured out the rule here, when you rotate and you're doing volumes, the cuts you make have to be perpendicular to your axis of rotation. Perpendicular to your axis of rotation. So that happened up here because we cut dx's and that was perpendicular to our axis. This way we're going to cut horizontally because our axis is vertical. So I'm going to make this cut. This time I'm making dy cuts. And the same thing's going to happen. And I'm, again, going to be able to draw it just with the same level of precision. So there's the inside. Here's the outside. And we're finding this area of this little sliver of a washer, the saddest donut you'll ever eat. And then we're going to add up all of them. So the difference is, for this question, now that we have decided or we have been told to do dy cuts, everything else in our integral has to be in terms of y. So we can only have y's in our integral. First thing I'm going to do is rewrite these things. So if this is y equals 3/2 x, I can convert that to x equals 2/3 y. So that's this line. That's a y. 2/3 y. Same thing here. If this is y equals 3√x, we can convert that to x equals y over 3 all squared. Whoops, y over 3. Okay, so now we just need to find outside radius, inside radius, and we are good. So start at your axis of rotation and go all the way to the outside of your circle. When you do that, you have started at your axis of rotation and you have gone to this curve. No matter where you draw your washer, you're at this outside curve. So that outside radius that I'm going to call big R is right minus left is 2/3 y minus -1, mix it, +1. Little radius, same thing. If I start at my axis of rotation and stop at the inside curve, then I have right minus left is y minus 3 squared minus negative, so +1. We'll put it all together in this integral up here that I started. We're going to do pi, big radius squared minus little radius squared. You just have to be so careful with your typing and parentheses and whatnot. And then our bounds are going to change as well because now when we make our rectangles, we're accumulating bottom to top. So these are all of our rectangles that we're drawing. They still start at 0, but they're going to stop at a y value of 6. And that's it, kiddos. Let me know if you need anything.